Cold Water Session 3, Part 4, Commissioning, Testing and Decommissioning Hot and Cold Water Systems. So I want you guys to be able to, at the end of the session, be able to explain the meanings of the term commissioning and decommissioning, give a basic description of each stage of the commissioning process, give a basic description of how to sound this test pipe, and that's it. Okay, so commissioning and testing. So commissioning is the process in which an appliance or a group of appliances are brought into use. And there's a step-by-step process to follow, and we're going to look at that in this session. So commissioning hot and cold water systems. The very first thing we should do when commissioning is a visual inspection of the installation. So we're going to check for things like, are there any open ends? Are there any obvious issues? Is it clipped correctly? Is there any damage? Are all the taps closed, etc., etc.? Okay, and then we would test the system. How we would test the system would vary depending on whether the system's entirely made out of metal pipework. In that case, we'd carry out a rigid pipework test, or if the pipework is made of plastic, or some of the pipework is made of plastic, and then in that case we'd want to make sure that we did the appropriate plastic pipe test. And there's a couple of those different types of plastic tests. But one of the key things to know is that we'd fill the system with category 1 water. That's a wholesome water, a cold water which comes from the mains. After we've tested the system, we would then flush the system. Generally speaking, you're just going to do that with water from the mains if in a domestic property. If it's a little bit different in commercial systems and industrial systems, you might need to use a disinfectant, perhaps a chlorine-based disinfectant, and we'll check that through as we go through this video. And then finally at the end, you need to do a performance test, basically check the system works the way that it should do. And finally, once we know that the system's working the way that it should be working, we can then hand over the system to the customer and explain how the system works and give them all of the appropriate documentation. So firstly, take a step back, do a visual check of the system, check are the pipes plumbing level, are they clipped correctly, is there any damage to the pipework, are all of our fittings closed, etc., are all of our taps closed, and then once we've done that, we can carry out a soundness test. Soundness test, as we said, is checking the pipes of sound, checking they hold water. And generally speaking, what we should do first and foremost is fill up with water first. Don't necessarily put it under pressure, and just take do another visual inspection just to check that there's no obvious open ends, no obvious leakages before we start pumping in extra pressure. But there's two types of tests we need to be aware of. One for testing rigid pipe. Rigid pipe is metallic pipework, essentially, for example, copper, steel, stainless steel, or for testing plastic pipe. And that's like, for example, polybutylene, cross-bonded polyethylene, MDPE, all this sort of stuff is plastic. Interestingly, if you have a mixture of rigid pipe and plastic pipe in a system, you should use a plastic pipe test, worth noting. Okay. And on Moodle, there's some documents on there which kind of show a flow chart of how to carry out each of these tests. But some of the key things, some of the key general principles we're going to look at now. Initially, all of our systems, whether it's plastic or rigid, you'd test it initially to 1.5 times the working pressure. And it's worth, like I say, filling it beforehand to have a wee walk around and check that there's no obvious leakage. In both cases, we'd use a hydraulic pressure tester like these ones on the right just here to bump that pressure up. And particularly with rigid pipework, it's considered good practice to fill the system with water half an hour, 30 minutes before the test, and this will allow the temperature of the water to stabilise. So you put water into it 30 minutes before the test to allow for temperature stabilisation. And at that point, you can also take a wander around and check for any open ends. So testing rigid pipe, as we said, pump up to 1.5 times the working pressure. You leave it on test for 1 hour. There should be no loss of pressure over that time period, and no obvious leaks. So when you take a walk around, you'd sort of check that, see that there's no leaks. Nice easy way to work out that 1.5 times the working pressure is to take the initial pressure, the working pressure, half it, and then add that half onto the working pressure. A couple of examples just here. So if you had the working pressure at 4 bar, you test it to 6 bar, because half of 4 is 2. Add that 2 onto the 4, gives you 6. So that's your test pressure of 6 bar if you had the working pressure of 4 bar. If the working pressure was 5 bar, half of 5 is 2.5. You take that 2.5, you add it to 5, 7.5. So if you had a working pressure of 5 bar, test pressure of 7.5. Easy. Okay. If the system contains plastics, it's worth noting that there's actually 2 different types of tests for plastic pipes, test A and test B. And as I've said, I've got a flow chart which describes these processes on eZone or Moodle. Okay. We would check for leaks during the soundness test and potentially before it as well. Yeah. And it's worth noting that actually, particularly where pipework's going to be hidden, you might want to do what's called interim testing. So just after you finish your first fix, maybe test your pipework after the first fix, because after that it's all going to be sort of hidden essentially. And if you want to be sure that it's sound, it's holding water, then you could do a quick test on it just to check that it's all good before the walls and the floors go in essentially. And when we do know that the system's sound, make sure that we put on insulation afterwards, because insulation potentially could hide some leaks. So once we've done the pressure test, we would then make sure that we flush it. And we flush it with wholesome water. We flush it with water from the mains, a nice cold, fresh, clean water. And we'd sort of check that everything's as it should be. For example, the water level in the cisterns are correct, and etc., etc. So after testing, we'd then flush the pipework. The flushing is essentially to remove any sort of debris that might be left in the pipework from the installation, maybe any flux residue or some of the flux residue from the pipework. And as I said, you'd normally use wholesome water, cold water from the mains in the domestic property, but for commercial or industrial installations, you might need to use a disinfectant, a chlorine-based disinfectant, to flush the system. And then if that is the case, then you would need to make sure that you speak to the water undertaker, your water supplier, before you discharge that water, or before you sort of flush it, to check that it's okay. So after you've flushed it and you've got the system ready to get up and running, you then do performance testing. Okay, performance testing is pretty similar for hot and cold water systems. Essentially, you'd check the pressure at the outlets, you check the flow. You'd actually do that. You want to check the pressure and flow under maximum demand, essentially. So you open up all the taps and stuff, and then check the flow rates and sort of see how this sort of the difference in opening the taps and stuff will affect the flow at different appliances, and that they all still work to an appropriate level even when other appliances are running. And for hot water systems particularly, you want to make sure that you measure the temperature of the water. And for heating systems, you might check the flow and return temperature as well. But for hot water systems, you want to make sure that the water flows to at least 50 degrees within a minute of turning on the hot tap. And for cold water systems, you want to make sure that the cold water is delivered at a temperature cooler than 25 degrees C. That's the absolute maximum of cold water temperature it should reach. This is just what we've been talking about just now. Okay, so yeah, if the flow rate to the pipework from the pipework to the appliances is a bit slower, potentially it could be a result of the pipework not being sized appropriately, or potentially could be a result of a valve not being fully open somewhere down the line. And worth noting, because you might need to work this out, you can calculate litres per second from litres per minute by dividing the flow rate by 60, because essentially you're changing it from litres per minute to 60 seconds in a minute, so you divide it by 60, and that changes it down to litres per second. Okay, there's a calculation you need to do in your test for that. So where can we find further information on commissioning? Well, actually, manufacturer's instructions is always a good place to look for not only just installing appliances, but also for commissioning them too. And particularly for sort of anything that might be gas fired, it's going to generally have a benchmark commissioning checklist that should be filled in on the top water cylinders. I've got these as well, and you'd give that to the customer when the job's complete. So when you finish the job, make sure you explain all of the controls to the customer and leave all of the relevant information with them. For example, the manufacturer's instructions, benchmark book, commissioning checklist, and give them a good thorough explanation of how the system works to give them that good last impression as well before you head off to another job. Temporary decommissioning, as we've mentioned before, it's when you take something out of commission to work in it, and then you sort of recommission it, you bring them back into process, back working again, so it works. If you do that, make sure that you sort of check that it's all working properly in the way it should do before you leave the property, and obviously make sure that you tell the person who lives in the property you're going to switch off the water before you switch off the water if it's going to turn off the entire supply, for example. Okay, and yeah, kind of obvious one here, I think, to some degree. If you're draining down the hot water side, make sure you turn off the heat source before you drain the system. Okie dokie. Permanent decommissioning, again, we've sort of talked about this before. When you remove something and you don't replace it, and we've got here an example on the right of a dead leg, and as we've mentioned before, make sure that you try and remove dead legs as far back as you possibly can, and it reduces the risk of stagnation and or bacteriological growth in the pipework. Now it is time for your task.